When you type a URL into your browser and you hit enter, your browser and the server start talking to each other. And that conversation happens in the language called HTTP. HTTP has had a few versions over the years, and every new version exists for a reason. Today I'm going to be talking about HTTP 1.1.1 and HTTP 2 majorly, but there's also HTTP 3. What was so painful about HTTP 1.1 that made the internet need an upgrade, and what did HTTP 2 actually change? Short answer is HTTP 2 made websites way faster without changing anything about the way you write code. So the same method, same status code, same headers, but the way the data actually moves between your browser and the server, that's what changed. To understand this better, we need to walk through what was slow about HTTP 1.1 first, yeah? If you've been following my API series, you know that I love to use this bookstore example that I have. Say we have bookstore.com, www.bookstore.com, and that page has HTML, as a CSS file, as a JavaScript file, as maybe 10 images. That's a total of 13 things that your browser needs to download to load that page. With HTTP 1.1, one connection can only handle one request at a time. So your browser asks for the HTML, waits for the full response, then asks for the CSS, and waits, and then asks for the JavaScript, and waits, and asks for the first image and the second image, and it waits one by one in a queue. A real life picture that can make you understand this is like going to a restaurant that has only one waiter. The waiter takes table one's order, walks to the kitchen, waits for the food, then brings it back. And only at that point, do they go to table 2. So every table is just there sitting there waiting. Our bookstore has 13 resources and they are loading one at a time. Yeah, that is going to be ridiculously slow. But of course, browsers are not stupid. So they figured out a workaround. Instead of using one connection, the browser using HTTP 1.1 opens 6 connections to the server at the same time. Basically 6 waiters now instead of one waiter. Each one handles one request at a time. So now things can load in parallel, yeah? But each connection is expensive. Before data can even move, the browser and the server have to do this handshake, the TCP handshake, more like, oh, you agree, I agree, we can do things together. And if HTTPS is involved, that's another handshake on top of that for encryption. In the real world, think about it. If your user is here in Tallinn, for example, and your server is in California, each round trip may take, say, 150 milliseconds. So opening a connection can eat half a second before anything useful even starts to happen. And you're doing that 6 times. So the workaround is not great either. And then HTTP 1.1 tried to fix this again with a feature called pipeline. So pipelining idea is simple. Several connections on one server, but they don't have to wait for each response. But it also had a flaw. The server had to respond in the exact order the request came in. So if you send request A, B, C, D, and A takes 10 seconds because the server is doing something slow, B, C, D are stuck behind it. So even if B, C, D were tiny and they were ready to go instantly, one slow response will still block everything behind it. This issue is called the head of line blocking. It's the reason why pipelining never worked out. Head of line blocking. I'm still kind of going to come back to this phase in my notes. Now, developers also tried to invent workarounds for HTTP 1.1. They came up with some really genius, really creative ideas when I was reading about these solutions. The first one was sprite sheet. So instead of loading 30 icon images, which would be 30 separate requests, developers will combine all those icons into one giant image. So now it's one image, one request. Then they would use CSS to show only the tiny portions they need. Instead of 30 requests, you now do one request. Another thing developer did was bundling. This is a very common concept. Instead of 50 small JavaScript files, developer will smash them together into one giant file, say bundle.js. Same with CSS. This is the kind of things that tools like Webpack were built to do. Another workaround they add was domain sharing. Since the 6 connections was per domain, developers will spread their files across different subdomains like asset1.bookstore.com, asset2.bookstore.com, asset3.bookstore.com. Now the browser opens 6 connections to each domain. So you get all of these parallel connections. All of these things were hacks. They were workarounds. They existed because HTTP 1.1 couldn't handle a lot of requests efficiently rather. And developers spent years optimizing around those limitations. Now the breakthrough in 2015, HTTP 2 was released. HTTP 2 was based on a Google experiment called SPDY. It's pronounced speedy. This is reminding me of a very popular Nigerian biscuit, speedy. The most important thing to understand about HTTP 2 is that it did not change HTTP itself. Get is still get. 200OK is still 200OK. Header still exists. From the code perspective, nothing changed. What changed is how the data moves. So 4 things that HTTP 2 changed about how the data moves. Number 1, HTTP 2 uses binary instead of text. HTTP 1.1 was sending literal text. Letter G, letter E, letter T, slash, space. That was what HTTP 1.1 was doing. HTTP 2 sends binary instead. Everything gets broken into like smaller chunks, and computer can pass binary faster, much faster than text. I have a video on how computers understand, or how, I think I'll link it below. It's an older video and it's very interesting. You cannot read HTTP 2 with your eyes the way you read HTTP 1.1, because HTTP 1.1 sends literal text. HTTP 2 sends binary. And the advantage is that your computer processes binary way faster. So HTTP 2 wins. Advantage is multiplexing. This is like the big one, is the headline feature of HTTP 2. One connection can handle many requests at the same time, not one at a time, all of them at the same time. So instead of one waiter taking one table at a time, imagine this. The waiter takes all the orders from all the table at once, brings them to the kitchen, and as each dish is ready, brings it out to whoever ordered it. So if table 3's appetizer is ready, it goes out. If table 1's main meal is ready, it goes out. Nobody is waiting for anybody else's food. Multiplexing. So your browser needs 13 things. You can request all 13 things at once on one single connection. The server rather, sends back pieces of the responses as they are ready. So there's no waiting, no queuing, one connection doing the work of 6 connection. And remember the issue we talked about earlier in HTTP 1.1 with pipelining, where one slow response can block everything else behind it. That doesn't happen in HTTP 2. If response 1 is slow, response 2 still streams back independently. There is no more head of line blocking. Problem solved. So all those art developers used to cope, sprites, sheets, bundling, domain sharing, they become unnecessary with multiplexing, because 15 small files are now nearly as fast as one big bundle now. Number 3 advantage HTTP 2 comes with is header compression. HTTP 2 uses something called HPAC rather, to compress headers. It works by keeping a shared lookup table between the browser and the server. So the first time you send your user agent string, it goes into the table. Every request after that just sends a tiny reference number instead of the full string. That's the issue itself in HTTP. I didn't mention this issue in HTTP 1.1. In HTTP 1.1, every request has to send the same header. Like you have to send your cookie, your user agent, your language preference, the content type. They are repeated information on every request. You don't have to do that anymore with HTTP 2. That was a problem in HTTP 1.1, but it no longer exists because HTTP 2 offers us header compression. Number 4 benefit is stream prioritization. The browser can now tell the server which request matters the most. The browser can say, hey, this CSS file is very critical for rendering this page, so send this one first. This image at the bottom of the page, that one can wait. You don't need to prioritize it. So the server can optimize what gets sent out first. Yeah. So 4 benefit of HTTP 2 over HTTP 1.1. Binary instead of text, multiplexing, header compression, stream prioritization. By the way, all of this is just knowledge. What does this actually mean for you as a developer? First, you probably don't even have to do anything. If you deploy on Vercel, Cloudflare, or similar platform, you don't even need to write your code any difference. This is already a server configuration thing. It's not a code thing. All of that work is already handled. So the main point is HTTP 2 is great, but it still has one problem left. HTTP 2 runs on top of TCP, and TCP does not know about HTTP 2's multiplexing. It just sees a stream of bytes. So if one packet gets lost, TCP pauses everything until that packet is recovered. So all your multiplex streams can stall because of one lost packet. And HTTP 3 fixes this by replacing TCP with a new protocol called quic. quic runs on UDP and it handles reliability per stream. So if one stream loses a packet, only that stream is paused, another stream can keep going. And it has faster connection setup. Connection can survive when you switch from Wi-Fi to cellular. And again, the switch for this from 2 to 3, you don't have to write any code for this. If you serve your sites through, say, Cloudflare or a modern CDN, your user are probably getting HTTP 2 on supported browser. So again, it's a configuration thing. So this video is more like a knowledge thing, understanding what goes on behind the scene. That's it. HTTP 1 versus HTTP 2 versus HTTP 3. Very straightforward. HTTP 1 is text-based, one request at a time. Developers spent years inventing workarounds. HTTP 2 is binary, it is multiplex. We have header compression. One connection can do the work of 6 connections, and most of the internet runs on HTTP 2 right now. HTTP 3 is still HTTP 2, but instead of TCP, you're now using quic. Most important takeaway is that your code doesn't change between any of these things. Your method, your status code, your header, they stay the same. What changes is how the bytes move, and that change made the web significantly faster. So that's enough HTTP yapping. See you in my next video. Bye.